So one theme that has come up repeatedly through the ECE conference is the fact that we have to prepare students to solve complex problems that don't exist today, potentially also with technology that doesn't exist today. So when students graduate universities, they have to be more prepared than ever to tackle these problems. And so NI is a strong advocate of enabling universities to challenge their students to think critically with project-based learning. As Andy Bell mentioned in his keynote, we don't want students to follow a recipe of instructions, but to develop those critical thinking skills that are very important for designing complete systems and even working across multidisciplinary teams. And so the NI academic platform is a simplified version of what we also use for our industrial customers. And we want our students to feel enabled to really focus on the fundamental engineering concepts being taught in their labs, but then have a sense of familiarity as they transition to their careers after graduation. This familiarity with the toolset allows them to make an immediate impact at their full-time position, solving some of these complex challenges that they're going to be tasked with solving. So for this one, I want to highlight two main trends that I'm seeing more and more professors and deans talk about. The first one is the use of, or the investment in multidisciplinary space. We heard from Texas A&M and Oklahoma State University about their new spaces dedicated for multiple disciplines to come together, to ideate, to try things out, and find solutions to some of the complex problems that they are being tasked with solving in their capstone designs, etc. And so we see more and more kind of announcements in showing us that universities are leaning more towards these multidisciplinary workspaces. And that's just something that we are monitoring and trying to build a platform that spans beyond just one specific course or one specific department. Another trend I see a lot of curiosity about right now is how to integrate remote labs to ultimately benefit a university's engineering program. And I think this is coming up for a few reasons. The first is that we are seeing an increase in interest in number of engineering student enrollments. And this might be placing a space constraint on existing labs as we're trying to accommodate more students. This can present a time crunch for students if they don't complete their work in their designated lab time, but they still need to complete the assignment before the deadline. And so these physical space constraints and time constraints are making some lab managers think, well, how can we enable them to complete their work if they don't have direct access to the lab? Another thing we're seeing, which I think is really interesting, is that some universities are evaluating complete engineering programs online, so no physical presence in a classroom. And so they're exploring ways so that these remote students can get the same hands-on experience, whether through student ownership models or a kind of similar remote logging into systems to complete their assignments. And this is to increase their competitiveness in attracting and retaining students and adapting to the modern era. And so I think we'll see a continued increase, a continued curiosity about how remote labs can benefit university programs. So ultimately, research is about forging a path forward through the unknown, trying to get to some type of solution or result that we're not quite sure what we're looking for because it's never been done before. We are at the frontier of what is possible today. And so project-based learning allows students to solve open-ended problems with known solutions. So they start developing those critical thinking skills, identifying multiple paths to get to an end solution. And this translates directly into their research experience, where they can forge a path forward, course correct, and continue working towards that end solution. And so project-based learning is key for students who really want to make an impact in their undergraduate research. This also translates to their careers because, again, once they start a full-time job, these companies are also tasked with solving problems that have never been solved before. And so knowing the process and the path and the steps to take to forge a path forward, develop a solution, and defend it is critical for the project-based learning through research through to industry connection. Yes. So I would say that Ad and I, we've evolved to be more of a consultant when evaluating what is feasible when a researcher has an idea. And so we like to help brainstorm what could be possible when trying to test an unknown result and work towards getting there. And then another thing that we've done is we have increased the number of proposal submissions requesting grant money because sometimes a partnership with an industrial partner can strengthen those applications. And so we're really proud of the efforts we've made to evolve those efforts. As far as best practices, I would say the biggest one that I see, especially when it comes to the transition of an idea, a discovery, into a commercial success, is the use of a flexible platform that can span across multiple industries, multiple domains. It can be adapted quickly, easily, and it's flexible. So that way the idea, when it transitions to industry, which requires a little bit more rigorous testing, they can just take what the researchers have done, built off of a flexible platform, and expand on it without losing a beat. And that's where we've seen some of the more successful transitions to practice with researchers, is the selection of a flexible platform.